Hi everyone, and thank you for tuning into our video today on interpreting velocity graphs. Over the last few days, we've been talking about position, velocity, and acceleration as rates of change. And today we're going to be talking about the same ideas, but we're going to be going more from a visual or graphical standpoint. So this first example is a nice lead-in, I think, so let's take a look at it. It says, the graph shows the velocity, v of t, of a student moving along a horizontal coordinate axis. So I think the first thing to recognize is that on what would normally be the x-axis, we're going to call this the t-axis. So this is the time axis, and this is going to be measured in seconds. And the y-axis, or what normally is the y-axis, you can see right here, velocity. So this is going to be v of t. And velocity, you can see here in very small print, it says meters times seconds to the negative first. Well, if you take s to the negative first down to the bottom, you're going to have this velocity measured in meters per second. So seconds versus meters per second. So I want you to understand that every y value on this graph represents a velocity of a student who's moving back and forth along a coordinate axis. So the movement's actually going on a horizontal line. So your student starts somewhere and they start moving right and left or standing still or whatever they're going to do. And these velocities just measure the different directional speeds as the student walks. Okay, before we start answering these questions, I just wrote down a reminder here. We talked about this the other day. If a velocity, because remember, velocity is speed with direction. It will give you really valuable information about which way your object is moving. So when velocity is positive, your object is moving upward or to the right. Or you could even say forward. When your velocity is 0, I put an X here, no movement at all. If your velocity, your directed speed is 0, you're not moving. And finally, if your velocity has a negative attached to the front of it, that's letting you know that your object is moving down or to the left. Now, in the case of this example, we know that positive velocities will represent rightward movement. So I'm going to circle that, rightward movement. And negative velocities will be leftward movement. Because in this first example, the student's not moving up and down like if you threw a ball up, a ball would be moving up and down. This student is moving right and left. Okay. So let's take a look at these questions. So the first question says, when does the student move to the right? And there it is. Movement to the right implies positive velocity. So you have to look at your graph and find where the positive velocities are. So the positive velocities, or the positive y values, since the velocities are y values, are going to be all of these. These are all positive y values or positive velocities. Now, I don't want to include time 0 or time 1, 2, or time 4, because as you can see, at time 0 and time 4, the student had a velocity of 0 and wasn't moving. So there's no movement to the right at these two endpoints. So when I answer this, I'm actually going to say t between, but not including, 0 and 4 seconds. Okay? Number 2, when does the student move? Move means velocity. Move to the left. So now we're looking for negative velocities. So where is their negative velocity? Negative y values. Well, you can see that that's going to be what's underneath the t-axis. So we're talking about from 4 over here, 4, 5, 6, 7, 8, from 4 to 8. But again, not including those endpoints, because on the endpoints, the velocity is 0 and there's no movement. So we'll say t between, but not including, 4 to 8 seconds. Okay, number 3. When does the student reverse direction? Okay, well, we know there will be a change in movement or the direction of the movement when we change from our right to our left. And there's only one way to change from the rightward movement to the leftward movement, and that's to stop and hit 0 and make that turn. So you would be moving right, you would stop, turn around, and start moving left. So where do the positive velocities change to the negative velocities with a 0 in between? Well, that is going to be right there at 4 seconds. So t equals 4 seconds. And I might put a little disclaimer here. Velocity changes from positive to negative at this time. There has to be a change in the sign of velocity in order for a reversal of direction to occur. It's just like the examples we did last week where you throw a ball up, positive velocity. At its maximum height, it stops. Hello, this is Gwen. Okay. Okay. Oh, gotcha. Yeah, sure. No problem. Okay, thanks, Marilyn. Bye. Sorry, guys. Little phone call there I had to take. Okay, so where was I? Oh, a ball. So a ball is going up. At its maximum height, velocity is 0. So velocity is 0 here. And it reverses direction and becomes negative. So positive velocity, 0, negative velocity. There has to be a change in sign on our velocity for us to change direction. Okay. Number 4, when does the student move at a constant speed? In other words, where are our speeds unchanging? Well, let me tell you what I like to do. And this, anytime, actually, let me say it this way. Anytime I'm looking at a velocity graph, which we are, it's showing us speed with direction. And all these questions asked about velocity. But here, they're using the word speed. I have to tell you what I like to do right away, since speed, and I'll even jot this down to remind you. We already have this in our notes, but I'm going to remind you. Speed is equal to the absolute value of velocity. Okay, so speed is undirected. I like to take my velocity graph and take the negative parts and reflect them across the t-axis. I like to take all these negatives and turn them positive. So speed, I'm going to go over with my orange highlighter. All this would stay, and now this would reflect upward. So the orange would be my speed graph. So I'm speeding up, staying constant, slowing down. Speeding up, staying constant, slowing down. And see, students will get that twisted up in their brains because if you think about it, when you look at this part of the velocity graph, you see it's going down. So you think, oh, my velocity must be decreasing. No. When you move away from the t-axis, you're actually speeding up. Just like here, when you move away from the t-axis, you're speeding up. You're just going left as you're speeding up. And then you stay the same, stay the same. And then here, you're actually decreasing your speed. See, when you graph speed, you can see it coming down. You're decreasing your speed just still in the leftward direction. So that can really mix your mind up. That's why when I am asked questions about speed, I like to just graph the absolute value. Now I can see I'm moving at a constant speed here and here. So I am going to say that I am moving at a constant speed from 1 second to 3 seconds. And I'm going to include those endpoints, because once I get to this y value, I stay there until 3 seconds. So I'm going to say for times between and including 1 to 3, and then union to show I have another set, and then this guy right here will put me between, let's see, 1, 2, 3, 4, 5, and 7. T between 5 and 7. And this is, of course, seconds. And that's because I'm flat, which actually tells me when I would find the slope, if I found the slope of this, it's 0, and we know the derivative of velocity is acceleration, so my acceleration is 0 here, meaning I'm not changing my speed. Okay, then they're asking me to graph speed. Well, I'm just going to say see orange graph above, because I already graphed speed up there. So just see my orange graph, and if you want to grab some color, and you can also recopy it down here. You can make a sketch, no problem. And last but not least, it's asking me to graph acceleration. So to graph acceleration, I have to remember the order of my derivative. So remember how it went position, velocity, acceleration. So acceleration is the derivative of velocity. So to graph the derivative of velocity, I have to use those graphical techniques from the last unit and graph the slopes of the tangent lines around the velocity graph from left to right. So this one I am going to make a new graph for. So this will be time and acceleration, a of t. And I am going over an 8-second interval, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, come down here. Okay. Now, the one thing is, though, I know I've drawn all over this graph. We have to go back. Acceleration is the derivative of velocity, not speed. So we have to go back, and I'll go over it one more time in yellow. We got to look at the slopes of the original graph, this one that came under. To be careful here that we don't accidentally find the slopes on the orange graph. So looking at yellow here, let's go find our slopes. So from 0 to 1, from 0 to 1, we have this line segment, and this line segment has a slope of up 3, right 1, so positive 3. So from 0 to 1, I am up here at positive 3. Now I close the dot at 0 because right here, if I drew a tangent line, it most certainly does have a slope of 3. But if I drew a tangent line here, this tangent line would be fighting with this tangent line. So I open this circle at 1 to show the corner and the non-differentiability. Okay. Now, from 1 to 3, right here, my slopes are 0. So from 1 to 3, slopes are 0. Open circles. Okay. From 3 to 5, from 3 to 5, all the way through, this whole segment here has the same slope. So the slope here is negative 3. So I'm going to come down here. This is from 3 to 5. My slope is negative 3. Oh, sorry, I'm like so low here. And then from 5 to 7, I'm back to 0. So I'm going to come up here from 5 to 7, back to 0. And then from 7 to 8, back here, I have a slope of 3 again, positive 3 again. So I'm going to come back up and close it on the endpoint. So this would be the graph of acceleration. So you can see that here I'm accelerating. My speed is increasing, which means I have a positive acceleration. And then I'm not accelerating. I have no acceleration because I'm not changing my speed. And then I'm accelerating here in the negative direction, back to 0, and then back to positive. So there you have it. This is kind of cool. I mean, look at all this that we did. This is how you interpret a velocity graph when you're asked questions about speed, acceleration, and movement. Okay, thanks for watching.